Let us continue the topic on project risk analysis or project risk management. Uh, so I hope I'm audible to all of you. So as we discussed yesterday, there are basically two types of approaches for project risk analysis, that is qualitative and quantitative. So in the quantitative category, there are mostly these popular four methods like expected monetary value, event tree and decision tree analysis, make or buy decision and break-even point. So this make or buy decision and break-even point are almost similar, but they are applied in different situations or context. Otherwise, the calculation will be very same. So let us begin with the first method, that is expected monetary value. I just introduced a little bit about that in the previous class. Actually, this is giving you a kind of expected monetary value associated with any alternative or any proposition or any option that you are having. You are trying to take to mitigate the risk. Suppose you have some options, some alternatives, but before selecting that option or jumping into that conclusion, one has to see whether if this option is taken, then what is the monetary value, because ultimately it is money or it is the capital that you are going to invest or profit or returns that you are going to get. So that is coming under, that's why it's under the quantitative approach. So here you are finding EMV, that is the expected monetary value, and that in fact is very simple. It is just the multiplication of the probability of that event being happen. Because as I said, when you are discussing about risk, you are not sure. If you are sure, then it is not a kind of risk you are talking about. All the risks that you are analyzing beforehand are having some probability between 0 to 1, and if it is more close to 1, so as you know, it is more probable to happen. So in that way, for each of your options that are going to take, or whichever alternative you are keeping as your option, you will check that which is giving you the least EMV, right? If it is a kind of loss, or maybe in other way, which is the option which is giving you the maximum profit. So in either way, you can utilize it. So let us see how this EMV is calculated. Am I audible to you? Someone please respond. Okay. So as I told you, it is simply the multiplication of the probability associated with a particular option or alternative with the kind of monetary impact it will have on the project. So just a simple multiplication. Okay, so you can see here, to calculate EMV, multiply this with this. Okay. Now let us take some simple examples to understand how this EMV can be calculated or can be useful. Suppose someone is betting for $60, that in the roll of a die, it will come up on number 4, right? In a betting, suppose this is a kind of your risk you are taking. And suppose you are betting for $60 that if number 4 comes, then I will win. Okay. So what is the EMV of this option or this alternative or this decision, right? So when you are playing this kind of gambling in die, using a die, so what is the EMV associated with this decision? That will come out to be minus $40, right? So you are at a risk of losing $40 because it's negative. It is negative. So this, I mean, theoretically, there is some chance that you can win, but the expected monetary value associated with this kind of gambling, when you are using a die and you are choosing a number, it's may not be 4, but any number out of 1 to 6, the expected monetary value is minus 40, right? So how this minus 40 came out? Because this is the multiplication of the probability of the options that are happening and the impact of that decision or that option on your pocket in it. So if number 4 comes, you will win. So what is the probability? 1 upon 6. So this 1 upon 6 will be multiplied by 60. That is positive. It's positive because this is you are going to get that back. So 1 by 6 multiplied by 60 plus there are other options that also may be happening, that are out of 4, the rest, out of 6, there are 5 more options which can also happen, right, in a roll of a die. So 5 by 6 multiplied by again 60, right? If you are losing, so 60 is going from your pocket. So that way you can see next slide, I think. Yeah. So you can see very simply you can calculate what is the EMB associated with this kind of risk taking, right? So 60 into 1 by 6 plus minus 60 multiplied. Why it is minus 60? Because you will lose it. So ultimately you are getting a number which is called the EMB, expected monetary value of this proposition, right? Similarly, suppose the same problem you extended to flipping of a coin, right? The same game, but for a flipping of a coin. So as you can see, the EMB is 0, all right? You are at a less risk compared to rolling up a die. Okay, so this way, this is a simple calculation which tells us whenever we have alternatives, then how to find the expected monetary value on the project and how to take the best decision in their interest. So let us take another example which is a bit more realistic towards project management. So for example, in a construction project, first I said you have to identify the risk. Suppose you have identified the risk as whether cost of construction material and some labor turmoil, right? These 3 you identified as 3 risks that can happen in your construction project. Now again you are finding the expected monetary value for each of these project risks. So first of all, as I said, before doing any quantitative project analysis, you need to have the probability of that event. Of course, again, as I said yesterday, it's not that easy to understand what is the probability. Perhaps I gave you the example of this Ukraine war yesterday, and I told you nobody knows what will happen tomorrow. And yesterday evening, you must be knowing that there is a huge probability of a war there. So these things happen. Nobody can predict such events. Similarly, for example, weather. But somehow, suppose you know there is a 25% chance of excessive snowfall that will delay the construction for 2 weeks, which will in turn cost the project $80,000. So this is the impact, right? $80,000 will be the cost impact on your project, just like your $60 in your previous example. So, you know, if there will be 2 weeks of work interruption, there will be a loss of 80,000 to the project, and there's a chance of 25% of snowfall. So this is one data regarding the first project risk. The second project risk is cost of construction material. But here you see an interesting thing. There is a 10% probability of the price of construction material dropping. I underline this. It's not rising, it's dropping. So in either way it can happen, right? Although it is a positive thing, but we consider that as a calculation in the risk. Okay, so it's a positive input. So there is a 10% chance probability that the price of construction material will drop. Okay, now if that happens, then it will save the project around $100,000, right? So this also you can estimate that if the price drops to this value, then we can save upon this much. The third project risk is taken here as labor turmoil. Again, you got some hint that there may be some labor unrest, people will strike, and there will be lockouts and things like that will happen. And there is only very few chance, 5% probability. So there is just a 5% probability of construction coming to a halt if the workers go on strike, right? Probability is very less, but the impact is huge, as you can see. The impact would lead to a loss of $150,000, right? Again, this you have also estimated. So if this is a situation, and you have got all the data, then easily you can find the EMV, the expected monetary value associated with each of these risks. Yes, this is the calculation. So how to quantify the project risk by calculating EMV? So 2 negative project risks here, that is weather and labor turmoil, and a positive project risk. Positive means you are gaining impact, the cost of material are dropping. So the sum, the total effect of all these you can add up to get a kind of figure, which is the total I mean positive and negative risk that is involved for your project in future. For example, for weather, you are finding this 25% multiplied by minus 80,000, so minus 20,000. Cost of construction material will be 10%, so 10 by 100 multiplied by 1 lakh, so that is 10,000, but it is positive loss. And labor turmoil is again negative, right? So it is just a 5%, so the value is less. Note, though the highest impact is caused by the labor turmoil, right? But the EMV is the lowest because of the probability, lowest probability. Okay, so the total project EMV based on all these project risks you can add up, and you are finding that it is still in negative. Minus $17,500 is the risk that this project may have to face in the near future, right? So that makes you give you an idea that okay, these are the, you can also prioritize which risks are more, I mean, you can categorize that which risk to be addressed with a higher priority because the EMV involved is more. So that kind of analysis you can do. Okay, so this is the approach of expected monetary value. Similarly, you can also, there can be situations where you have 2-3 alternatives, you want to take the action, right, beforehand. So you can check what is the EMV of that. So that option which is giving you the highest positive EMV or lowest negative EMV, you can go for that, right? So this way, it is just a multiplication of probability with its impact, monetary impact. Okay, so that is expected monetary value. Okay, the next one in this quantitative category. In fact, there are two, inventory and decision tree. So you should look into these two methods as very similar. The only difference is that inventory is somewhat a method where you are having two options only out of each node, right? If this happens, then what? Else what? Means only two, right? Yeah. Whereas the decision tree can be have more than two options, right? So event tree and decision tree, they are used in this problem situations to find the best solution. And again, also in this case, you can make use of probability, right? You can use probability and the impact also. But compared to the previous method, right, like EMV, here you are moving ahead in the event sequences, right? So let us see how this event tree is working. An event tree is a graphical representation of a series of possible events in a sequence, right? In a sequence it happens. This approach assumes that as each event occurs, there are only two outcomes, failure or success, right? Okay, only two options. So in fact, I remember some character in that old office in the serial. That person used to say, "Ya to ye hoga, ya ye hoga." Means only two options are there. The similar situation is here in event tree. Either success or failure, kind of binary, 1-0 kind of situations. So that also you can make use of. And you can use probability in that also, but the sum of the probabilities would become 1 because there are only two options. A success ends the sequence and the postulated outcome is either the sequence terminated successfully or was mitigated successfully, right? So somewhere you will stop. So where you will stop, if it is addresses the problems completely, then you can stop here. If it is not addressing, you can go on and on as long as the problem is completely solved. So that is, for instance, fire starts in a plant, right? There is a fire accident. This is the initiating event. Then the fire suppression system is challenged. There must be some fire suppression system that will sense the smoke. Then maybe it will sprinkle water, right? So that is a fire suppression system. So it will be challenged. So it will come into action. Maybe it will not work because your sensor is not working or your controller is out of I mean, it is not working. So in that case, what is the next? What is the next? So likewise, I'll give you one example how this event tree can be used for such situations. And same thing is applied to any kind of risk perceptions and how to find the solution ultimately by following these kind of various options. But the only limitation with event tree is that at each node, you have only two options you have to use, either failure or success, yes or no kind of thing. Okay, if the fire suppression system fails, then the fire is not extinguished or suppressed and the accident sequence progresses. Then something next will happen. Maybe you have some other system which will detect it. Then there will be maybe alarm, or maybe security person will get to know the accident, and he will also inform. So whatever the next sequence will follow, and you will plan accordingly that if this thing happen, then what are the probability of my corrective actions and what is the impact of that also. So that also you can see. So let us take one example. Yes. So this is a very good example to understand the event tree concept. Look at the figure. Okay, you take some time to understand it. See, we are starting from the left. So there is an initiating event, and that is fire. Right. Suppose you are planning for your fire accidents or fire hazards in your plant or in your project. Right. Suppose somehow there is a fire because of short circuit or because of any other negligence. There is fire. Right. So the initiating event is fire. Then what is the next event? Event one is you have a well-placed fire suppression system. Right. As I said, maybe you have some smoke detectors and it is supposed to suppress the fire, and it will be get actuated. Right. Now it will get actuated means it is supposed to get actuated, but it may fail also. So there is a probability of success and there is a probability of failure also. So if it is success, right, then directly you can go to the end state. What is the end state? The end state is minimal damage, because water will be sprinkled, there will be alarm system, people will come and they will control it, right? Because it is success. If it is failure, see, this is the feature of event tree. At each node, we have only two outcomes. या तो ये होगा या वो होगा, right? Failure, success. So if it is failed, means that your event one failed, your fire suppression system failed, then there is another system in place, that is fire alarm system sends signals to fire department. Maybe this will be activated. You have some other means of getting the fire alarm system. Maybe someone saw it and started the fire alarm. So if that is the case, event two, then there is also a probability of success, right? So if that happens, then there will be damage, but the damage will be, the end state will be moderate damage because it will take some time, and within that time there is moderate damage to your plant. And if it is failed, right, the second system also failed, then what happened? Then there will be severe damage, right? So these kind of event trees are used to quantify your various risks and your solution methodologies or alternatives or options or different decisions at different points. And you can associate cost to this also and probability to this also, so that you can find which kind of solution for the kind of risks you are foreseeing for your future are the best solutions, right? So these are the quantitative tools. I think there is another slide for this same problem, but with probabilities. Yes. Now let us attach some event probabilities to this problem, right? So the events are in the left column, leftmost column, then the probability in the rightmost column. So as you can see, what is the probability of fire being taking place in your plant? There must be a probability, right? This is the initiating event, and the probability is 0.001, right? 0.001 is the probability that fire will happen. Of course, it is very conservative value. Uh, then, what is the probability that the fire suppression system will actuate? Right. Again, this is a very well designed and placed system. So the success probability is almost 99%. In the 99% cases, it will be actuated and it will work. But still, there is a 0.01% probability that it may fail to actuate. Okay. Similarly, you have the fire alarm system, the second event. So its probability of success is 0.995 and its failure is 0.005. So if these are the values, right? So the again I said, getting these values is also a very big challenge and task, right? But somehow you got it through your experience, through your case studies, through your experimentation, or some other means. Somehow you got these probabilities. Again, it is very costly affair, but if you got it, then you can do the rest of the analysis. So now event tree with the path probabilities. Now let us see what is the complete path probability. Now here it is not a single event that you will multiply with the probability. There are multiple events happening simultaneously. So as you can see, when it is branching out, what is the probability that there will be minimal damage, right? Suppose you are interested to know what is the probability that if you are using this kind of system, I mean fire extinguishing system in your plant, what is the probability that our plant will have minimal damage? Suppose you are interested in that figure. So what is that? It is simply the multiplication of these probabilities. As you can see, there is some multiplication theory of probability. So the success of event 1, right? The success of event 1 will be multiplied with the probability of initiation of fire, right? So 0.001 multiplied by 0.99. So it is almost 0.00099 or closely 0.001 probability, right? Or just 0.1% probability that there will be minimal damage, right? Then, all right. Then similarly for other paths, you can calculate the probability. For example, for the moderate damage. For the moderate damage, first of all, you have to multiply the, now you have three probabilities you have to multiply. One is the probability of fire with probability of failure and with probability of success of event 2. So all the three are multiplied, right? This is something like PA into PB into PVC, PC kind of. So ultimately you are getting a probability value, right? Similarly, for severe damage, the probability is very less, as you can see. Probability is very less. So it is least likely to happen because the probabilities associated with this are very low, right? So 0.001, that is the probability of fire, multiplied by probability of failure of event 1, that is also very less, 0.01. Then multiplied by failure of the event 2, that is also 0.005, right? So these are the probability of the various paths and the probability of happening of that kind of end state, right? So this way, of course, this is one example, but depending on your kind of problem and kind of risk that you are looking for your project, you can associate the corresponding probabilities and you can get to know what is the probability of happening of that particular end state and how to address it or mitigate it. Do you have any questions in this? Can you hear me? Am I audible? You are following all this? Event tree and all that?
Yes, sir.
Right. So let us proceed to decision tree. As I said, decision tree is also becoming more popular nowadays because when you are talking about these machine learning methods, decision tree is also considered as a a crude method of machine learning, and people are also using decision tree. So what actually happens in the decision tree? Actually, you are again creating many paths, and you are associating that paths with some probabilities, and maybe you can include the cost include in that also. So it is also considered as a kind of mm, supervised learning method of machine learning. So that way it helps also. But in case of, it is a very old method of analytical or quantitative tools for management practice or decision making. You can split your options and you can check which option is giving you the highest benefit so that you can opt for that. But probability is playing a very big role in this decision making tool, which is we are talking here in the context of risk analysis. So a decision tree is a simple way to get a visual display of the uncertainty and the various decision options for project risks. So as I said, when we are talking about the risk, it is a kind of uncertainty we are talking about. So it can deal with that. So it is a graphical approach that can be used to evaluate decisions under uncertainty. There is some noise here in the background. Please bear with me. Okay, so one can also use MS Excel add-in, and you can find the decision tree option is there. So it is very easily available. So you can explore more on that. To determine the expected monetary value of a risk or a decision, the following steps are required. So here the one thing is which is distinct, make it distinct from the other method, that is the event tree. Now at each node you can have more than two options, right? But in event tree you have only success and failure. I mean only two options. But here you can have more than two options and you can attach probability to all the multiple options, but the sum of the probability should become one. So mutual exclusive events. So identify the scenarios that could occur, right? So these are the steps to construct a decision tree. Identify the scenarios that could occur. Determine the probability of each scenario. As I said, the most difficult part, how to determine the probability. Determine the monetary value associated with each outcome. That is the impact, cost impact. Multiply the probability times the monetary value of each outcome. We already know EMV. Sum the outcomes to get the expected monetary value, that is the EMV of the risk or decision. Very similar. So here the only thing is that you have multiple options you can include. So that makes it look like a tree. Okay, some example. Suppose you have four systems. Some systems that you are comparing for your project. And these systems are denoted as a BCD, and they have some initial cost, as you can see in this figure. Please take some time to understand it, this figure. So these are the systems, and these are the system costs, means the initial investment in that. You are trying to find the best method for the kind of risk that you are finding. And for each system, there are some data which is given, probability of success and postulated benefits, right? So these figures are actually the kind of benefits that will get out of the system, right? And the probability of that happening is also given here, right? Suppose you are adopting system A, right? So the probability that it will behave in a good manner is 0.3, and the corresponding benefit is this big figure, right? 1 with 8 zeros. Similarly, the probability that it will work in a moderate way is 0.5, and that benefit is given like 25 and 6 zeros. And the probability that it will behave poorly is also 0.2. That is the probability of success, you can call it. And when it is behaving in a poor manner, it is in fact costing you in negative. It is not giving you benefit, but it is costing you negatively. So that is -4 with 6 zeros. Similarly for all other systems, right? For this kind of data, to select the best option, it may be system or it may be a decision also, any strategic decision regarding your risk, right? So it is just, for example, I'm saying it can be a physical system or it can be a decision also. So if this is a situation, you can construct a decision tree, somewhat like this, right? I think is visible, or I should make it full screen. All right. So take some time to understand what it's actually doing. You forget about this left-hand side, best benefit system C. That will come that will come to the end, right? But you begin with this system below which there are 4 systems, A, B, C, D, 4 circles. And the initial investment is mentioned below that, $1 million and all that. Okay. Now this system A can have three states, right? 3 states: good, moderate, poor, and that is for all the systems, right? Maybe for some system it will be not 3, but in this case they are all 3. Again, you are finding the EMB kind of thing. So in the EMB, you can see you will multiply the probability with the benefit associated. I have shown you in that table. So if it is happening in the good way, so it is probability is 0.3, and that is multiplied with the impact on you, that is 100 million. So some figures. Similarly for moderate, similarly for poor, but poor was negative, so you are getting a negative. Same thing you repeat for all the rest of the decisions or systems. So you are finding some EMVs for all. Now the only simple thing is that, or if you are adapting system A, you just add all these things. Just like you add in that case of that construction project example. There was weather problem, there is labor turmoil, but finally you add up them. There is something positive, something negative, but you add up. Similarly, for system A also, you add up all this. For B, you add up, right? So finally now come to the result or the best benefit. This left-hand side of this figure, as you can see, the best benefit is given by system C, because the sum of all these may be the highest, right? Because here the your perspective is to get maximum out of our system. Again, it depends on what way you are using. It may be something. See, there are 2 terms which are used in this context. One is benefit, the other is cost. Benefit, cost. These are 2 managerial terms which are used for this purpose. Benefit means something positive you are getting. Cost means it costs you, means you are paying some way or other. You are paying. That's cost. So it depends that whether you are focusing on benefit or you are focusing on cost, right? Whatever it may be, or it may be combination of this. For example, in this example, it is combination of this. There is positive and there is negative. So if all the things you are comparing for cost, then all are obviously negative. So in that case, you will go for the system which is giving you the least negative value, isn't it? Because your perspective is there to find the minimum cost system. Similarly, suppose you are going for benefit value, then you will try to take something which is giving some option which is giving you the maximum benefit, highest value. So in this case, I think it is the highest value that is taken because we are talking about benefits, right? Okay, so as you can see here, the same calculations are given for system A. You have just find the EMB of each option, that is good, moderate, poor, and then you have added them, right? Okay, I missed out something. There is the initial cost of the system, isn't it? There is the initial cost. So you have to add that also. I mean, you have to subtract that also. You can see these are the benefits you are getting. That is coming out to be 41750, right? Out of that, you have to subtract your initial investment, because each system is of not of the same price or investment here. They are of different costs, so that also you have to include. So the net benefit is the benefit. Okay, so again you can see the same terms are used here. Net benefit is the benefit minus cost. Benefit is this sum of all these benefits from all the different options, and you subtract the cost. So you are giving the net value, net benefit, that is 40750. Similarly, for other systems also you can find, but as you can find here, the system C is giving you the maximum value, that is 585, then 50, right? So you will opt for that option. You will opt for that. So this is a very simple approach of decision making, and I hope you got the idea about decision making. I mean, decision tree tool. It's very similar to event tree tool, but the only difference that you can have more than 2 options, 4, 5, anything you can give, but their probabilities, as you can see here in this table, the probability of good, moderate, and poor, if you add up, that has to become 1. You can have more varieties of options, but their sum should equal to 1. Okay, so do you have any questions in this event tree and decision tree? Have you heard of decision tree earlier? अच्छा, कहीं पढ़े थे? कहीं? अच्छा, किस ब्रांच में हो? कहाँ पढ़ाया गया था? अच्छा, out of your, I mean, regular academic courses. Is it? I mean, not in your course structure, but out of that. Right. Very good. Very good. So as I said, in machine learning, decision tree can be used, but mostly people are preferring deep learning and ANN kind of machine learning algorithms. But decision tree, as I said, a very crude method for machine learning, and it can be applied also. Okay. Like there is another method like called logistic regression or regression analysis. That also comes under that level of machine learning methods similar to decision tree. But the deep learning or the artificial neural network based methods are at a higher level of machine learning. All right. So decision tree is a very old approach. It was there, and usually managerial decisions are made using this kind of decision tree methods. It's very simple. It can be applied in any situation and very useful also. So you have multiple options. You can just check in terms of their. Again, I will say, getting the probability value is the most difficult task. But if you have any fair idea about the probability, then maybe it is very useful because you will find the cost impact of that decision, and you can definitely get a very useful solution out of that, because the option will be the best one in terms of your benefits. Okay, so any questions from others? Have you understood this, or do you have anything to put in here? We have 68 students in the class. Is it clear to all of you? Okay, so with your silence, I assume that you have understood. And it is almost 9:48. So I think I should not begin the next topic, the tool which is called the make or buy decision. Maybe we'll keep that for the next class. So in the next class, we'll hopefully complete make or buy as well as break-even analysis, which are very similar, as I said. Right. So that will end up our kind of quantitative risk analysis methods for projects. Okay, then if you have any questions, please go ahead. Otherwise, I will stop here today. Are you attending any offline classes in your branch? Not yet. Good. So whenever you feel like attending offline classes, please let me know.